Okay. In today's lesson, we're going to review from what you did in Algebra 1 of factoring, solving, and graphing quadratic functions. As the next unit is going to be all about quadratic functions and doing things different with quadratic equations. So we wanted to spend a lesson here and review what we learned in Algebra 1 with factoring them and solving them and graphing them. So you can see in the notes there are, I think, 5 things. I can't remember. There's factoring by grouping, there's factoring by difference of squares. The notes go through 5 different things, but we're only going to look at factoring today. So we're only going to look at A, B, and C in these video notes, and then when we come back to class the next day, we will continue from there. So, first of all, understand the difference between factoring and solving. Factoring will have no equal sign. So if you see that, if you see a quadratic function and there is no equal sign, you know that you need to factor. If there is an equal sign, then you know you need to solve. The first thing that you need to do, and I put the list of sort of steps here, the first thing you need to look for is a GCF, a greatest common factor, something that you can divide out or something that's common between all of the terms. So in this particular problem, in the first problem, there is no GCF. There's nothing that I can divide everything by. So I can skip to B, which is using the AC method. Now, depending on who you had for Algebra 1, there are various ways of doing this. I'm going to show you the way that I taught it. I firmly believe that this is the easiest way. So you can do it however you want. If you remember the way you did it last year, you can do that. But we start out with identifying our A, our B, and our C. A is always the number in front of the x squared, B is always the number in front of the x, and C is always the number that's by itself. So A, since there's no number there, we assume it to be 1. B is -5, and C is -24. We then do, why it's called the AC method, is you multiply your A times your C. 1 times -24 is -24. And then you just bring over your B, which is -5. And then you had to figure out what 2 numbers multiplied to be your A times C, or -24, and added to be your B. So some of you guys are pretty good at figuring this out in your head, but if you didn't know what multiplied to be -24 and added to be -5, I would probably start with just writing what things multiply to be 24 in the first place. Things like, 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. So those are the sort of things that you want to look for, and then you want to look for a combination that you can add together to be 5 or -5. Now you can change negative signs, meaning you can make either one of these numbers positive or negative, but usually you can see the combination of 3 and 8 can be 5 in general. So how do we get it to be -5? Well, if I make the 8 negative and the 3 positive, I can add up to be -5. So those are my 2 factors. So now the final step is to do what I call the dead cartoon eyes, which is a set of parentheses with X's in them. They sort of look like the way a cartoon would look if they were dead. Yeah, the X's in the eyes. And then all you do is just drop down your factors. So -8 goes here, +3 goes here, and that is your answer. So that's how we factor quadratics. Now, look at the other example here. So that one's an easy one. So if you look at the other example here, we can pick out something here. Now, here you'll notice, and you need to notice, that a couple things give it away. One, you have an x to the third here. You have an x to the third, so that is a red flag that something needs to happen, something needs to change here. This is not a normal quadratic. The second thing you might notice is that all of them do have x's. So I can take the x away from all of the terms by just factoring it out, by taking it out. So by taking an x away from each term, I now have 3x to the second minus 5x to the first minus 2 with no x. And now I can proceed to factor what's on the inside. So again, my a is 3, my b is negative 5, my c is negative 2, a times c is negative 6, bring the b over, that's negative 5. What multiplies 2b negative 6 and adds to be negative 5 is, I'll give you a little time to think, negative 6 and positive 1. Okay. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So those are my factors. So again, I'm going to bring down my dead cartoon eyes. Now one thing that is different about this, now back in Algebra 1, notice how my a is not 1. Okay, back in Algebra 1 you might have been taught to solve this using grouping. You might have been asked to split up the middle term into into these two factors, and then asked to factor by grouping. But there is an easier way. Okay, because your a is not 1, what you're going to do? So you're going to still do what you're doing here. I'm going to draw my dead cartoon eyes, bring down my factors. But now, since your a was not 1, I'm going to divide my factors by that a. So what happens here is 6 divided by 3 becomes negative 2, so minus 2. But the 3 on the second term does not divide evenly, so you have 1/3. So it's a fraction. So what ends up happening is you can't have a denominator, so the denominator ends up just going in front of the x, which makes this 3x plus 1. And that is your answer. I know, crazy easy, right? Use that as an example, and go ahead, pause the video, and try to do the 2 examples, and I'll show the answers here in just a bit. Okay, so here are your answers. One thing that I forgot to do on the previous question is this x here. You have to remember, and it is your third thing up here if you look at the steps, make sure your GCF is in front of your factors. So since we factored out an x in the very beginning, that x then has to be there in the end as well. So, and here's your answers. So I factored out a 2, solved, factored this, and then the 2 went out in front. Here, there was nothing to factor, so I just did the AC. 10 times 3, negative 3 is negative 30. My factors are negative 6 and 5, so when I bring those down, I then have, because my A is not 1, I have to divide both of these numbers by your A. Now, 6/10 did reduce to 3/5, and 5/10 reduced to 1/2. But then, because there is a fraction, that denominator then gets pulled out in front of the x and makes it 5x minus 3, and then 2x plus 1. So your answer would be that. Okay, now this was the old way of doing factoring, but it is useful if you're given it in 4 terms. So if I'm given my problem here in 4 terms, I can just go right into grouping. So what grouping was is you took the first 2 and put parentheses, and then you did the second 2 and put parentheses, and all you did was find a GCF in both cases. So for example, in this first one, the GCF between 6 and 9 was a 3. And since they both had x's, it was 3x. So when you wrote your leftovers, you just divided both terms by 3x, getting 2x plus 3. The second one, there is no GCF. 2 and 3, there is no common factor. So you do have to pull out a common factor in grouping, even if it's just a 1. But by dividing by 1, nothing changes, so it's still 2x plus 3. What you want to look for is that both of your parentheses are the same. If they both are the same, then you know that you did this right. Finally, you bring your GCFs into one set of parentheses, so 3x and then a positive 1. And then bring down your factors of 2x plus 3, and that is your answer through grouping. The same thing can be applied to more complex problems, like the second example here, where you have a bunch of different variables. You're still going to group because there are 4 terms you can use grouping, and pull out common factors. Notice how in these first two, you do have an x that's common and a y. So the x and the y will come out. So if I take an x and a y away from each term, I'm left with just x and minus 2. The second one has a common factor for numbers as well as letters. So there is a 6 that's common and a z that's common. Now, the rule is that if your first number is negative, you have to pull out a negative. So since 6 is common, I'm going to take out a negative 6 and a z. So dividing both terms by negative 6 and taking away a z, you're left with just an x, and then negative 12 divided by negative 6 is negative 2. Again, look for these to be matching, and then you bring down your GCFs, so x, y minus 6z is 1, and then the x minus 2 is the other. Okay, go ahead and try this one problem here. Pause the video, go ahead and try it out, see what you get, and then I'll post the answer. So there's the answer to the problem. The GCF in the first one was 5x. Pulled the 5x out here and left with x plus 2. Here it was a 4, pulled out a 4, left with x plus 2. They're the same, so I know I did it right. 5x plus 4, and then the x plus 2. One last thing is to factor using difference of squares. Depending on your teacher, you may or may not have learned that. So let's look at that. Factoring by difference of squares. So this is pretty easy to recognize. What you want to look for, first of all, are there 2 terms? Second of all, difference of squares, meaning that it is subtraction. And then you're looking for perfect square terms, meaning that both of your terms are perfect squares. So, for example, 81 is 9 times 9, and x squared is x times x. Down here, 16 is 4 times 4, and 49 is 7 times 7. They're perfect squares. You look for that, and if you see that, you don't have to do this, but it makes it a lot easier. So what you're going to do, to use difference of squares, the sort of formula, not formula, but what it is it's a minus b and a plus b. What that means is that you're going to have 2 sets of parentheses, one with a plus and one with a minus in the middle. And all you do is square root both terms. So the square root of x squared is just x times x, so x will go in the first set there. And then the square root of 81 is 9, so you just put 9 in the second set. And there's your answer. It can even be used to do a little bit more complex problems like this. So you have 4x to the 4, a bunch of perfect squares here. So again, I'm going to have my parentheses, one with a plus, one with a minus. I'm going to square root each term. Square root of 4x squared. The square root of 4, first of all, is 2. And the square root of x to the 4th is actually x squared times x squared. So it's x squared. So that goes into both of these. And then the square root of 16 is 4. So 4 goes in the second one. And that is your answer. You can see how having the knowledge of difference of squares can make these problems a lot quicker. So real quick, go ahead and try this last problem, and I will post the answer once I'm done here. Okay, so there's the answer, what you should have gotten. Square root of 16x squared is 4x, because square root of 16 is 4, and then square root of x squared is x. So 4x goes in both of the first slots, and then square root of 49 is 7, and negative 7, so that goes in the second slots. And that is factoring using the difference of squares. So all we went over in this set of video notes is just factoring. So there was factoring, just straight factoring of quadratics. There was factoring by grouping when you do have 4 terms. You do not need to use grouping anymore ever again. Unless it already gives it to you in 4 terms, then that's the only reason why you would use it. And the last one is factoring using difference of squares. This is when you have 2 terms, and you notice that both terms are perfect squares. That is it. So we'll continue from here on the next lesson talking about solving and graphing. Thanks for watching.